Hello, Mr. Betts here. I want to take a look at a couple examples where we're going to use linear partial fractions to rewrite an integrand into a form that we can actually evaluate the antiderivative. So the idea here is we want to take the expression in our integrand and we want to rewrite it. And we're going to start by factoring that denominator. So I'm going to do some side work here. So I'm going to do this down at the bottom. So 2x plus 11 over x squared plus x minus 6 is the same thing as x plus 3 times x minus 2. And we want to think of this as the sum of two fractions where we've gotten a common denominator of x plus 3 times x minus 2. So we're going to write it just like that, x plus 3, x minus 2. Now, these are linear partial fractions, meaning that the numerator is just going to be a constant. The numerator is always going to be a degree, cannot be has to be a degree less than the denominator. So in this case, since the denominator is linear, the numerator has to be constant. So we're just going to put variables. I like to use capital A, capital B. That's typically what you'll see in a textbook. And we're actually going to get a common denominator for these two and add them together. When we do that, we're going to be multiplying the first one by x minus 2. So we have a times the quantity x minus 2. And then for the second one, we're going to multiply b times x plus 3. And our common denominator then is x plus 3 times x minus 2. So now what we want to do is solve for a and b by making choices for x. So I'm going to choose x equals 2. And the reason I'm going to choose x equals 2 is because it's going to make that 0. And what I'm doing is I am saying that that expression is equal to that expression. So if x is equal to 2, we're going to have 2 times 2 is 4 plus 11 is 15 equals b times 2 plus 3, so 5b, and b is going to be 3. Then I'm going to choose x equals negative 3, and when x is negative 3, we're going to have 5 is equal to negative 5a, and this term here is going to be 0 now, and so we get a equals negative 1. So this tells us then that this expression is equal to negative 1 over x plus 3 plus 3 over x minus 2. So with this side work, I can take this integrand now and I can rewrite it as negative 1 over x plus 3 plus 3 over x minus 2. Multiple terms in the integrand. I should use some sort of grouping symbols, usually parentheses, but brackets would work too. And now we have this in a form that we can actually take the antiderivative of. With the coefficients being 1 in the denominator, it's pretty easy to do this without using substitution, but we can choose u equals x plus 3. So du equals dx, and we can make a substitution and end up with a natural log. So this is going to be negative 1 natural log of the absolute value of x plus 3 plus 3 natural log of the absolute value of x minus 2. And then don't forget your plus c. In a multiple choice exam, there's a good chance that this is going to be written in a different form using log rules. So remember, when you add logs, you can multiply the logands, the insides of the logs. When you subtract, you divide. The coefficient can be made an exponent. So this expression is the same thing as the natural log of the absolute value of x minus 2 to the third power over x plus 3 plus c. So in a multiple choice exam, you might see that as the option written as a single log. If it's free response, you do not need to do that. This example is very similar. So we're going to do some side work to do some partial fraction decomposition. Factoring the denominator, we're going to have x minus 4, x plus 2. So we'll make that a over x minus 4 plus b over x plus 2. Getting our common denominator. Looks like that. And then making choices for x, we can say x is negative 2. So that's going to give us negative 9 is equal to negative 6b. That gives us b equals 3 halves. And then x equals 4 is going to give us 3 equals 6a, and a equals 1 half. So we can use that to rewrite this integral as the integral of, so a is going to be 1 half, so 1 half over x minus 4 plus 3 halves over x plus 2. Multiple terms need parentheses. And then we evaluate the antiderivative. Again, with the leading coefficient being 1s here, then you don't need to use substitution, although it's essentially what we're doing here. So this is going to be 1 half natural log of the absolute value of x minus 4 plus 3 halves natural log of the absolute value of x plus 2.